Alrighty, here we go for another set of notes and lessons for y'all to work on. Alright, so our goal on this one is that we're going to be able to find the midpoint between 2 points, and if I get a chance I might go ahead and also add on to this where we will find a point that's a fractional distance from one endpoint. We might look at that later. We shall see. Anyways, what are we talking about here? We are talking about a midpoint, and I'm going to back this up just a wee bit. Alright, the midpoint of a segment is the point that's halfway between the endpoints of the segment. So that's kind of like, oh, I already knew that, sir. So the midpoint is the one that's halfway in between, exactly. And that's really about it. Okay, so what's the formula? Well, there's kind of two different formulas, but they're really the same. The first formula is if you're dealing in just a line. Let me rephrase that. On a number line, like it's a flat surface, or there's just, it's not diagonal, kind of, I guess you could say. It's not on a coordinate plane. It's on a number line. Okay, so back this up just a wee bit. Let's go right about here. I'll put it right here. Okay, so that formula is just basically you add the x's and then you divide by 2, or you add the 2 points. Let's say that, and divide by 2. Not worrying about signs or anything like that, just adding those 2 points. Okay, and then from there, and so like you can see here in this example, I'm saying the midpoint of 25 and negative 8 is 8.5, or 8.5. And the reason why is because if I add 25 and negative 8, I would get 17, and 17 divided by 2 is 8.5. Now, if you left it as 17 over 2, I would be more than happy with that. You can do that. That's okay. All right, so the next part. So let's find the midpoint on a coordinate. So like number lines are easy, but what about if it's on a coordinate plane? Well, that means then we have x's and y's. And so the idea there is that we want to add the x's and divide by 2, add the y's and divide by 2, and we're going to get like 2 separate answers that we will combine into 1 point. Simple? Easy? Yes, it is. So let's see. So here's the midpoint. There's 2 points right here. So what do I do? Well, all you got to do there is basically just say add the x's, which is negative 6 and 1, and divide it by 2. Add the y's, which is 3 and 0, and divide by 2. Now, if you want to do that on the calculator, remember you'd have to do each one of these separately. Whoops, wrong button. Let's try that again. Each one of these separately, and if you want this little fraction, Control Divide would allow you to be able to do the fraction, at least on the Inspires. So, negative 6 plus 1 divided by 2 should give me negative 5 divided by 2, which I'm going to leave as a fraction. 3 plus 0 is 3, divided by 2 is just 3 over 2, and I would leave that as a fraction, and I'm done. Simple. I know. I knew. Anyways, I saw some comedy show that would do that a lot. Anyways, so, all right, any segment, let's see here. Let's get this drawing here. Okay, so any segment, line, or plane that intersects a segment, notice the key word there is a segment, at its midpoint is called a segment bisector. Okay, so here is this line P. Now I'm going to redo this in green so y'all can kind of see. If I look at PQ, this line right here, dun, 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 dun. Okay, keep in mind that when you start seeing these little broken lines, that means like it's like something's blocking the view. In other words, the line keeps going, but the plane is blocking us from seeing it. So it be kind of like we're like keeping it going. So that means that, like, you don't see it any further. So it's not on, like it's going in a different direction. Okay, so you can see here this line, M is the midpoint. Okay, M is on plane A, so that means A cuts the line in half also. The line KM goes through that midpoint M, so that means that line cuts PQ. And even J, which I for some reason forgot to put the J, JM goes, obviously goes through M, so it cuts PQ. So all of those are bisectors, segment bisectors of PQ. Plane A, line KM, and line segment JM are all bisectors of PQ. Now keep in mind the idea of what a bisector is. That's going to be a very important term because that's going to mean like letting you know it cuts things in half. All right, so what happens if I'm given, say, the midpoint, and I need to find an endpoint. Okay, well, the idea there is we want to substitute where needed, then solve. The steps will be the same, kind of keep that in mind, just maybe slightly different numbers. So we're going to substitute where needed and then solve. For example, K is the midpoint of line segment JL, and L is negative, or is 3, negative 5. Find J. Well, okay, so if I put the numbers where they go in the formula, the 3 and the negative 5, and here's the formula, the 3 and the negative 5 would go where the x2 and y2 are. And notice that K is what they're equal to. So the numbers of K. So notice that these numbers did not go into the formula. They're what the formula will equal. So if I separate each one of those separately, I can easily find out those answers and solve. Now, there's only 2 steps for each one of those to solve, and those steps kind of are the same. You're going to get rid of the divide by 2 by multiplying, and then you're going to add or subtract. For example, here we go. So you can see here what I'm going to do is I'm going to multiply both sides by 2, and then I'm going to add or subtract. And you can kind of see me working that out, and to get the x1 is negative 5, and here multiplying by 2 on this one, adding. Notice that I changed the plus negative 5 to just minus 5, because plus and negative is the same thing as a minus. Okay, so what's the opposite of a minus 5? Plus 5. And then I could say get 9, so J is at negative 5, comma 9. So that midpoint existed if the point was negative 5, 9, and at 3, comma negative 5. Okay. And again, if y'all ever have any questions on these, make sure to ask. All right, last example I want to go over. So I'm going to go ahead and I'll split what I was going to do. Instead of having like one really long set of notes, I'm going to split it in 2 smaller sets. Okay. If PQ, this one takes is this. Okay, let's go ahead and do all this drawing. If PQ, find the measure of PQ. I didn't write that, I should have. If Q is the midpoint of PR. So look, notice here I'm not giving you any numbers, I'm giving you some variables. So, but I do know that Q is in the center. These two are equal. Okay, remember that's the line for congruency. Okay, so that means that I can set 9y minus 2 equal to 14y plus 5. So I'm going to set those two equal to each other. And just like I said always, I like to do variables to the left, numbers to the right. So 9 minus 5 is 4y. 14 plus 2 is 16. Divide by 4 and I get 4. Now here's the thing. That doesn't give me my answer. My question was finding PQ. So I need to find this distance. So to do that I need to put the 4 in place of the y and say what is 9 times 4 minus 2. 9 times 4 minus 2 is 36, minus 2 is 34. So line segment PQ is 34 units or 34. Anyways, so that pretty much covers everything what I want to cover today. If you have any questions, again, guys, make sure you ask in class. Take your time, let me know. All right? Thank you so much for your time. Y'all take care.